Good morning. So like she said, I'm Gavin. I'm the VP of Architecture for AWeber Communications. We're an ESP located in the States, and I've been using RabbitMQ for just over 10 years or so. I am the author of RabbitMQ in depth, and if you're so inclined, there's a nice little code that my publisher gave for 40% off the book. I highly recommend you check it out. It's a great way to learn RabbitMQ from the bottom up, which is somewhat the opposite that most books take in their approach to how they teach something, but I feel like it's a really good way to learn why Rabbit does what it does. So before I get into the real part of the presentation, I wanted to talk about perspective because my talk today, by and large, has a lot to do with opinions. I was speaking with a coworker, and I have a reputation at work at being somewhat knowledgeable about RabbitMQ, and he told me he had a really important RabbitMQ question for me, and that was, is this the front of the rabbit? Or is it the back of the rabbit? Is this the fluffy cottontail, or is it the nose? And I had never really thought about that before. Here's a logo that I'd been looking at for 10 years, and I hadn't really thought about which side of the rabbit was. I always just assumed it was the face. So front or back? Are you guys going to be able to move on past that? For me, that was like, wow, gave me a little bit to think about. In that same vein, I really like the fact that Obi-Wan admitted to being a Sith Lord in this quote in the movie. Only a Sith deals in absolutes. I make a lot of absolute statements. I make a lot of, don't do this, don't do that. But everything is relative, and in that vein, all generalizations are wrong. I'm going to make lots of them. Keep that in mind. So I'm going to start with a story. This was actually when we just started to get into using Rabbit in production under heavy load, and we had moved from ActiveMQ. And this was in 2009, which brought us this awesome game called Farmville, which fortunately I never got sucked into, but it was pretty popular for the time. And ActiveMQ was doing well for us at the time, except for the fact that it had lots of memory leaks, and we had to restart it in production fairly regularly, which is not the kind of thing you want for a message broker. We were in the middle of migrating, or not migrating, I'm sorry. Our app was a PHP web front end talking to Rabbit. And if you're not familiar with how that works, you got the awesome Internet Explorer web browser of the time, Apache with mod PHP, and every web server process or connection was a different back-end connection. And PHP at the time was connect, start the program, execute the program, stop the program, clear out the space, which meant that every single connection to RabbitMQ was short-lived. It would connect, and it would disconnect. The problem with that is that there are 7 stages to negotiating an AMQP connection. And we learned really early on that under our load, under our scale that we had, over 100 web servers, a really high level of concurrency, 100,000 requests per second or so, that our app was slower using Rabbit. And it was because we didn't fundamentally understand the nature of how our app was talking to RabbitMQ, and we made some assumptions, and they weren't correct. We had moved from using Stomp and ActiveMQ, which was a very simplistic protocol similar to HTTP, made a socket connection, sent a bunch of stuff, disconnected, to connect, negotiate your connection, and then publish your message and disconnect. And so that overhead of that initial time basically added milliseconds of latency to our environment where we were very millisecond latency, it was a concern for us. So ultimately what we ended up doing was taking and writing a middleware to sit between our Apache backends and RabbitMQ that was an HTTP service that had long-lived connections in Python to basically lower the load on the RabbitMQ cluster to have long-lived connections and yet still process the large amount of publishing that we were doing. And so there was a conclusion that we came up with. High connection turnover in RabbitMQ was bad. That we needed to stop using PHP, well, that really wasn't true. That we needed to use HTTP to AMQP as a proxy. And you'll even find that Cloud AMQP offers a similar type of offering built into their product these days for PHP or other environments that have short-lived connections, because it really does impact the performance of your application. That brings me to my next story, which is about reinventing the wheel. Same group, same organization, and it was 2009. I miss those people. And I was in the middle of figuring out how we take and move from our existing implementation where we were sending these messages and we needed to know what kind of message we were sending so that we can be on the other end and receiving it. And by convention in ActiveMQ, we're publishing to a specific place and we're consuming from a specific place. But now in Rabbit, we have all these other options. We've got this topology that we can create with complex routing scenarios and publish the same message and have it go off into different places for different purposes. And so how do we categorize it and provide information around that application in a way that allows us to somewhat future-proof our potential usage and provide information? And so the VP of Engineering and I got into a room along with our VP of Architecture at the time, and we had a vigorous debate about our message payload and strategy. And what came out of that was something like this. They were strongly advocating putting everything in the message body. Figuring out, what kind of message it was, when we sent it, along with additional information, what application was sending it, and then having an attribute that was like, and here's the message as well, which is fine, except for AMQP has that type of connotation built into it. RabbitMQ messages have these things called properties, and I'm sitting here saying, well, we're using this tool, in for a penny, in for a pound, let's start using the contract as it's defined. That's like crazy. Doing something like this to me was like going back to SOAP over HTTP, right? Taking all the contract out of the protocol we're using and putting it in the payload. And then having some sort of system by which we correlate the payload and how we decode it in our programs with the message that's going, instead of using what's built into the protocol. So, at the time, I'm advocating, well, hey, here are the properties that we have. We've got type. Let's use it. You want to know when the message was sent? Look, we've got a timestamp, guys. Come on, let's think about using this the right way. And you know what? We may not always be sending JSON across the wire, so let's make sure we're using content type and content encoding to describe it. Again, built into the contract. And finally, something that I actually have come to really appreciate and is probably one of the more understated aspects of message properties, the app ID, in convention saying which application is publishing your message. I found over the years that being able to take a message and use these properties to figure out information about messages in my message bus are really helpful. And they may not be at first blush. They may not be to the developer when they're writing the application as they're thinking about them at that time. But one of the really keen things about the flexibility in Rabbit is the fact that you can start using your messages over time in ways that you didn't originally think about. So if that's the case, why not future-proof and provide as much context as you can in the built-in data structure that describes the message? So our conclusion there, of course, was to keep message data, metadata out of the message body, because that's not really where it belongs in an AMQP message. It belongs in the properties. And so let's use those. They didn't agree with me. And somewhere along the line, I think we ended up in a compromise. And I've used that principle and tried to apply that principle going forward. Again, 2009, a long time ago. Instead of moving into another story, I want to go down a rabbit hole. Just real quick, from an operational perspective, running RabbitMQ, it's hard to get the things you need to care about right. It's really easy to get all set up, get your applications in place, and then make sure that you've got monitoring in place so that you know when things break and you can respond to them and fix them. And if you take a naive approach to that, it's really easy to create paging fatigue for your on-call resources because maybe there's fluctuation in your environment, and if you don't take a holistic approach to your paging, you're getting paged at 2 in the morning because of some condition like, gee, I've got 2 more messages in the queue than I expected. That's not good. So what I've found in multiple environments with people monitoring RabbitMQ is that they basically have 2 patterns of use. And I think this is kind of a beginner intro stage in how do I monitor, make sure that everything running in RabbitMQ is running the way that I think it is, which is, are my queue depths larger than they're supposed to be? Which I think is generally a good thing to check for. And do I have the number of consumers that I expect to be there? Those are pretty basic things we check for, right? The problem is those things are naive. If I have a queue and I've got 100 consumers on it, and I have an environment where, let's say that I'm running in Kubernetes and resources may go away and come back, or I'm running in AWS and they take resources away from me and then they give them back. I want to program for resilience, not consistent state. And so why should I monitor for consistent state? If I'm expecting 100 consumers, do I really want to set an alert threshold that says if I have less than 100 consumers, wake somebody up at 2 in the morning? Probably not. But if I have it at a threshold that is either, a fraction of what it's supposed to be or 0, it probably makes a little more sense. And do I really want to have an alert that just says, hey, if you've got 100 messages in the queue, because you should always have 0 messages in the queue because we're optimized for throughput to keep our queue depths at 0, somebody should know about it. And I'd say that's probably not the best way. So some of the patterns that I like to suggest is alert when a queue has 0 consumers. That tells you something is really wrong. If you're in an environment where you are going for the paradigm of pets versus cattle or pets versus chickens, as I like to say when I'm in India, you can not guarantee that you're always going to have exactly the number of consumer applications that you want, but you can make sure that when something's really wrong, somebody's being woken up. Instead of just having a naive approach to saying, hey, my queue depth is at 1,000 messages, so alert and wake somebody up, what you really care about is, are my consumers consuming my messages? And maybe I've got 1,000 messages, but if I'm running along at a decent clip, and because this is a queue, I've had a spike of work, we don't need to wake anybody up. But if we have a trend where we have 1,000 messages, and over the last hour it's been slowly accumulating and the velocity of consuming messages has gone down, then that's maybe something we want to look into, because maybe there's an operational issue that's causing our throughput to go slower than expected. That's a really important way to look at how you can avoid pager fatigue with regard to the application. One thing that I think gets passed up a lot is looking for problems in your ecosystem. And if you write your applications in such a way where RabbitMQ, your consumer applications, when they're acting or they're responding to messages and saying, hey, I've processed this message, so let's move on to the next one, or I processed this message, but there was a problem with it, and so I'm going to negatively acknowledge it, and I'm going to kick it back, or I'm going to reject it. Watching for those rejections, I think, is an important thing to do, because it can, again, indicate if your applications are written in a way to use those as an indication of success and failure. It can indicate a failure rate that may be worth looking into. But you can't stop there. Dead letter messaging in combination of that will allow you to accumulate those messages in another queue, which will allow you to interrogate those messages and figure out, hey, what went wrong? Beyond looking at logs, let me look at the raw data so that I can try and recreate the conditions that caused me to negatively acknowledge it in the first place. Finally, one of the things, if you're running an HA cluster, and let's say that part of your normal operational process in that is to do restarts for upgrades or anything like that, one of the things that you'll find that can happen if, for example, you're not completely distributing your HA queues across your entire cluster, and even in that scenario, you can find that there's unbalanced distribution of ownership or primary ownership of those queues on a particular node. Or maybe if you are doing with a 3-node cluster, you've got HA mode of exactly, and you've got 2 as your value for the params, or that, how many nodes are going to have HA for that particular queue. You'll find that over time you will end up with an uneven distribution of those queue ownerships and the secondary nodes across. So keeping an eye out for that. Maybe that's not something you throw an alert for, but you've got a dashboard for that kind of shows you that there's an uneven distribution, because that will create a hotspot within your environment that will cause CPU, memory, network utilization, disk utilization to be higher on the nodes where the hotspotting is occurring than on the other nodes. So my third story, if you can't tell, I'm going through a bunch of stories and fun things like that, is I started at AWeber in 2014. I went into the environment and they were already using RabbitMQ. They were using some of my software to interact with RabbitMQ, which was really cool. Kind of go into a new environment and see that they're already using things that I wrote. Yeah, neat. Now, this was 2014, and to take you back to what was happening in 2014, we got cool Android watches and cool Apple watches for the very first time. It's hard to think that that was only, what, 5 years ago or so that these new devices came into play. And what I walked into was an environment where developers were disgruntled. They had predisposed ideas about what they should be doing. They didn't necessarily make the technology choices that they were using. They were told that they should do things this way or that way. And like many times when programmers think that their way of doing things is better than the way that's currently being done and they should use other technology, they were predisposed to set up the environment for failure without actually looking into what they should be doing. So in this case, they had a 3-node Rabbit cluster, and they had a set of publishers that were throwing data into it and consumers that were taking data out of it. A pretty simple pattern, HA queues with HA mode all. So what happens in HA mode all is the publisher comes into the exchange, they put it into a queue. That state with that queue has to be synchronized with the state of the queue across all the other nodes. So I publish a message, it comes in, and then I've got a consumer over here, and every message in is synchronized, every message out is synchronized, and of course that creates a bottleneck. In addition to that, they were publishing with delivery mode 2. Delivery mode 2, for those that aren't aware, is the mode that tells RabbitMQ persist the message to disk. So not only are they coordinating across all 3 nodes, they're also saying write these messages to disk when they come in. These were fairly big messages with big data payloads that were used within our system for figuring out trends in email delivery and reputation for our customers. And so every single one that would come in would get synchronized across to disk for everything and go out the other side. Not a big deal. I mean, that's built into Rabbit. Again, not an issue. But we take it a step further and we find that they're virtual machines. So not only were they virtual machines, they were small virtual machines comparatively to the workload that was being put in. So in this scenario, we've got a Rabbit cluster, and conceptually, if I was running on one hypervisor, for example, I've got all 3 nodes, but because we were really concerned about not losing messages and high availability and how many 9s that we have to meet for our uptime, it's a different node across different hypervisors, and we're coordinating across all of that. And so I started asking questions. I'm like, well, did you think about the throughput requirements of your application before you started? Did you make sure that we're provisioning the right type of virtual machine as far as number of cores, amount of memory, amount of I/O capacity? Well, no, the ops guys take care of that stuff. They just set up the cluster for us, and we started publishing to it. And as it comes to fruition, in investigating the whole scenario, we didn't need to ensure that every message was written to disk. With HA mode, we've got 3 servers that are ensuring that we're not going to lose any messages. And the whole point of writing it to disk was to ensure that there was durability of the message and it would persist across restarts. Well, if you don't restart all 3 clusters or all 3 nodes in the cluster at the same time, you don't have an issue, right? And it turns out that our primary culprit there was the amount of I/O that was required for the size of the message that was being published in to persist it to disk and to do it 3 times and deal with all of that. So ultimately our conclusion was that the VMs were way underpowered for what they were doing. Right? We're expecting Rabbit to act like a database server, but we're not providing it the same type of infrastructure that we would provide a database server. We also had these things running on oversaturated hypervisors. So there were lots of VMs on each of these hypervisors, and they were all competing for resources in the work, but somehow the engineers were thinking, well, this is Rabbit's fault. It's slow, it's terrible. And it turns out, well, no, you were basically putting it on a overly congested piece of infrastructure, and that's where your speed issues came from, in combination with the demand that you were putting on it by having it do additional I/O on every node. So turning off delivery mode 2, bumping up the resources and moving things around within our operational environment got us to a point pretty quickly where all the objections fell away and everything was running and all good. So yay. So I want to take you down another rabbit hole here and talk about networking. This is probably not the thing that you were expecting to come in and talk about at a Rabbit talk. But I feel like really understanding, having a holistic understanding of your application stack, your operational environment, and the various levers that you can move to affect performance and throughput and your application are really important, even if they're areas that you yourself don't necessarily interact with on a regular basis or even at all, because there's that ops group over there that deals with this kind of stuff. How many people in this room are familiar with the OSI model? A good percentage of you. That's great. The OSI model is just a way that we could describe our networking stack and talk about the various layers of things that impact how data gets moved from one place to another. And with regard to most things that we do, in this case, we care about the Ethernet frame layer, the transport layer at layer 4, which is TCP/IP, and our application layer, which of course is AMQP. Or that could be HTTP for the Rabbit management interface, or API, or STOMP, or MQTT. And one of the things that I like to point out in talking about this stack and the model with regard to this is we're just dealing with data structures and data structures on the wire, but we're dealing with multiple layers of data structures as they go. So at the Ethernet frame layer, you can see we basically have a data structure that says take this message from this place to this place. Here's the body of the message, and here's the checksum for the message. Pretty simplistic. But you can see that ultimately at each one of these different layers, in essence, it's the same type of thing. So on top of Ethernet, we add IP, and that has all sorts of fun information about the payload of the message that we want to send. Where is it going, and where is it coming from, and how big is it? I forgot, how big is it is also one of those things in ether types, that third part of the Ethernet frame. And then on top of that, we put TCP, and that gives us basically control over additional information. But we always see that we have these embedded payloads all the way down here to the AMQP frame, down there. Makes sense, right? So if we then start to think about AMQP, RabbitMQ, sending messages back and forth, and we take it all the way down to that first source, the Ethernet frame. The default MTU in most networking environments is 1,500 bytes. And that only gives you 94.93% frame size efficiency. What that means is that for the amount of data that we're putting into that frame versus the overhead in the data structure for that frame, it's only 94% efficient or 95% efficient. And when it comes down to it, after TCP, that means that we only have 1,460 bytes available to us in the payload of the TCP frame to send our RabbitMQ frame, which could be part of a message, it could be a command, etc. Then we think there are at least three frames for every RabbitMQ message that we publish, which is the RPC command, which is I'm going to send you a message, and here's the exchange to publish it to, and here's the routing key to use for that message. We're going to send a frame with the content header, which is going to include how much or how big the body of the message is and all of the message properties associated with it. And then we're going to have one or more body frames, and within that body frame, your message. And that could be the first 131K of data if you're publishing big messages, or a single frame if it's smaller. And now we start thinking about how do we divide that up into 1,500 or 1,460 bytes, right? You start doing math around what's happening. How many packets per second am I going to be sending in my application as a high velocity publisher to be able to support the size of data that I have, and then that backs you into what kind of infrastructure do I need to be thinking about with regard to my networking stack and my networking devices, network cards, all that kind of fun stuff within my messaging solution. And that finally brings me to talking about jumbo frames. So 1,460 bytes is probably okay for a lot of the RPC style messages going back and forth between Rabbit, but if you have messages that are larger than, let's say, a K, you probably want to be thinking about how can I optimize my networking side of things. And if you have the ability to use jumbo frames, that gets you to 99.14% frame size efficiency as far as the overhead for sending the messages on the Ethernet stack versus the amount of payload that's there. And those kind of things make important and subtle differences in your application performance. It's not all just layer 7, as it were. So this is a fun one. This is an interesting debate, let's say, about how you should be managing the runtime configuration of Rabbit. And when I say runtime configuration, I'm talking about your exchanges, your queues, your bindings, maybe your virtual hosts, your users, policies, permissions, all that kind of fun stuff. Again, we're talking about 2014. We got this awesome selfie from Mars. And while the awesome people at NASA, JPL, and everybody else involved in a project of sending machinery to another planet to go investigate and take pictures, I was dealing with a much less important in the grand scheme of things technological debate. We were going through a process of upgrading from an old RabbitMQ version, and when I say old RabbitMQ version from, it was 2014, I want to say it was like a version from 2010, maybe something like that. You know, set it up, forget about it, it's running in the environment, to whatever the current version was at the time. And that should be a fairly straightforward process, one would think, right? You basically, whether you're doing blue-green, A/B, setting up multiple clusters, moving traffic around, ideally it should be the kind of thing that with some pre-planning, configuration changes should be pretty easy. Unfortunately, during that process, we ran into opinionated consumer applications. In essence, on startup, these applications were declaring the exchange and declaring the queues and binding them. And in that statement as it is, that's pretty innocuous, right? It's not a big deal to have those things happen, and pretty normal. When you go look at the RabbitMQ tutorials, that's one of the very first things that they show you. Declare your exchange, declare your queue, bind them, now do your things. Great. But what happens when somebody decides at the time that they're writing their code that they want a direct exchange, but then 3 years later we decide, well, you know, we really should be using topic exchanges because it provides us better flexibility in what we're doing. Oh, and by the way, the person who made the decision is no longer with the company, didn't document anything, left us with code running in production that we had no idea, was hard-coded with expectations of how the topology in RabbitMQ would be set up. When it comes down to a consumer application, really all it needs to know is, where do I connect and tell Rabbit I want to get messages from? And ideally, those are configured things, not things that are hard-coded in code. So as we went through this process, we got like, I want to say 90% of the applications moved over really easily. Configuration management's a wonderful thing. Being able to go through and change applications quickly allowed us to get everything going. And that's when we ran into problems. And this fine gentleman, Dan, who I worked with at the time, he and I went into a room and spent about a day fixing hard-coded applications with hard-coded expectations of what was running in our RabbitMQ environment and how it should be set up. You could tell he looked really happy about that, right? That's about how I felt as well. It was a real facepalm moment. It was somewhat difficult to work through. But when we think about the motivation about what the developers were doing, they weren't wrong and they weren't bad, right? They were trying to create automated, repeatable configuration. That's a really important thing. It's a really good way to ensure that your environment is consistent. You wanted to make sure that there was a reliable, consistent source for that topology to make sure that the applications still work. And that could be used for disaster recovery, right? It's one of those things where you want to make sure that the environment is set up correctly for your application to do the things that it's supposed to do. Finally, for them, it meant for very easy client application configuration, because if the client application is the thing doing the configuration, you don't have to worry about the other side, right? The application's doing it all for you. From my perspective, though, that was really taking RabbitMQ and only using part of its functionality. Right, there's a lot more to Rabbit than just the AMQP protocol and the ability for these applications to connect and do these things. You've got the management UI. You have configuration settings that you could create to have RabbitMQ do on load when it starts that sets up the topology for you. And so really then it was, well, how do we take those applications with those hard-coded expectations, still meet all the criteria of having automated, repeatable, consistent configuration across our environments, but take the control away from the application itself, just make sure that the contract is met for what its expectations are. And what we ended up settling on was a bidirectional Git-based sync process. So in our internal GitLab repository or GitLab instance, we have a repository for each one of our RabbitMQ clusters, and that repository holds a JSON file that is the topology of the RabbitMQ cluster as you would get when you do a export from the management UI or the API. Well, kind of. And the idea there is that if a developer wants to add something new to the topology, I'm not going to force my view of using the management UI to control everything on them. They can make a PR, because it was really important to the engineering team at the time that everything goes through a code review process, even if it's not code. So let's have a Git repo, let's do merge requests, and make sure that everything happens the way we want it to. We'll pull that down onto the cluster into a local Git repo. We'll use scripting in our configuration management to automate the application of those definitions into Rabbit. And we'll pull the current state of Rabbit out, pull that into the Git repo. If there's anything different, we'll commit it and push it back to GitLab. And it was a nice compromise because it satisfied my concern. I didn't want to be constrained. So one of the things that I've found over time is that due to whether it's operational issue, upgrades, whatever I needed to do, I liked the flexibility of going into the management UI and making changes in our production environment to accommodate whatever the event was and not being constrained. Maybe I needed to offload all of the traffic on a single node in a cluster to another one, so I set up temporary queues where I've explicitly said, hey, put this queue over on this node, and now let's move all the messages there, and let's move the client applications over there. I like being able to do that. And so this was a nice compromise. But one of the problems is that the RabbitMQ API that exports the definitions and JSON in its own nature is non-deterministic in its sort order. So if you take just straight up, I'm just going to do an export from RabbitMQ's API of these definitions, and you put it into Git. Every time you run that, the file is going to change, even if nothing in the file has changed. So we threw together a really simple Python application that does deterministic sorting of that file, so that way we're only making commits when actual content changes. And our conclusion there is don't use config management for configuring RabbitMQ's runtime state. You'll see this in things like Chef, Ansible, others where you'll have objects. You know, declare my exchange and here are the properties. Declare my queue and here are the properties. We've avoided that, and we've tried to make it to where it is a somewhat democratic process as to how that stuff gets managed. It's still in Git. It's still applied via configuration management, but it's not done in code. Now, again, all generalizations are wrong. If that doesn't work for your organization, it doesn't work for your organization. Worked well for me. Publishers and consumers should not declare exchanges. I'm going to stick with that one across any environment, because exchanges and queues and bindings, that's runtime state that is used to reflect your operational environment, and it's somewhat of a separation that you would think of in the same way that you would think of a load balancer or maybe a router. Yes, there should be that configuration, but do your applications really need to care about it? Probably not. And finally, there are applications that do need to care about it. For example, if you're using Rabbit in an RPC paradigm where you've got, let's say, a web service that is publishing RPC requests over Rabbit using the reply to header, it's going to need a place for the replies to come back to, so it should declare an exclusive temporary queue for itself to receive its replies. That's not the kind of thing that you want to keep in a Git repo. Getting close here, I promise. We're going to go down the rabbit hole one more time. We're going to talk about blue-green upgrades, because this was another common theme that I found across environments. It can be, it's getting a lot easier, but it can be hard to upgrade RabbitMQ in production. How do you do it in a non-disruptive way? So if I'm going from, let's say, 3.6 running on Erlang R19, and I want to be really cool and go to Python, to Rabbit 3.8 running on Erlang R21, I can't just, swap out a node one at a time. Now, if I'm staying on the same Erlang version and I'm in the later versions of Rabbit 3.7, I think 15 forward, and I want to go to 3.8, or I want to go to 3.8.1, I actually can now make those types of changes, but in the past, it's been pretty difficult. And so basically, there's a really simple pattern to follow using built-in tooling within Rabbit, the shovels, to set up your two clusters. So we're using Git for our topology, right? And so we know what all of our definitions are that we need to be able to set up our new cluster. So let's use configuration management, stand up our new cluster on new virtual machines or as a new set of a deployment in Kubernetes or whatever your topology looks like. And then we've got our publishers and our consumers on our blue cluster. And we simply move our consumers over to the green cluster, and we use shovels to bridge the two clusters together. And one of the reasons why we start with consumers is by using the shovel's acting as a consumer on this queue here, and it's just moving it right across to the same queue name on the other node, or the other cluster. And in essence, we can ensure that there's a consistency in our application that is non-interrupted, other than the restart that's required or the reconnect that's required for our consumer application to connect to the other side. In the next step, we move our publishers. So our shovels are still going. Any messages that are in our old cluster are still there, being moved across by the shovel. But now we've moved our publishers across, and our application is still working. We wait until there's no activity in the blue cluster, and we get rid of the shovels. Pretty easy. Key takeaways that I have for this: always use the contract AMQP provides. That's the properties, the exchanges, bindings, routing keys. Don't naively monitor or queues for messages ready or consumer counts. Monitor for the absence of consumers and queue depth in relation to velocity. Make sure your infrastructure supports your workload decisions. That's a really important one. And in most cases, you don't need delivery mode 2. Don't declare your exchanges and queues in your applications, and use blue-green deployments. Any questions?
What's the monitoring stack you use?
I'm sorry?
What's the monitoring stack you use?
We're in a half state. Older stuff is a combination of Diamond and Nagios, and these days we've been moving towards Telegraph, using Grafana for our paging on our front end, and a mix between InfluxDB, Prometheus, and Graphite. Yes?
So you mentioned not having a need to use persistent messaging. My question earlier.
So yeah, you mentioned not having a need to use persistent messaging. My question earlier was going to be, so presumably that means you keep the system up all the time and you never have to turn it off. So I guess the blue-green deployments, is that a way that you can run 24/7 without having the problem of shutting down and losing messages?
Yes. That combined with HAQs in clusters. Because if you have a cluster and you're ensuring that the messages are replicated across all nodes in the cluster, you have a far lower probability of losing any messages.
Okay, a quick question on how you do the blue-green. When you move the say the producers from one system to another, is there a way to kind of, do you forcibly remove the producing applications? Is there a way to say, now move over there, or how do you orchestrate that?
So in our environment, we use console as our service discovery layer, and each cluster has the same generic name. It may be cluster a.service.production.console, but it also has a tag associated with it, which is blue-green. So in our configuration, we could target and say, go to the green cluster instead of the blue cluster. And with the way that our applications are written, they basically will make that switch automatically when we make the key change in console that says go here instead of there.
Thank you.
Mm-hmm.
What is an optimal way to balance out the queues in a HA cluster?
What's an optimal way to bind the queues?
Balance the queues.
Oh, to balance the queues. There are a couple applications out there that do that. I'm totally blanking on at least one of the names. I wrote a Python script to do that. I think it's called RMQ cluster rebalance, but there are a number of tools that do this, which basically provide a way using the built-in policies within Rabbit to move the primary queue from one to another and kind of take into account the number of queues and figure out what the optimal strategy is.
Thank you.
Before you guys go, I have these awesome Rabbit stickers. If anybody wants one, just come up and grab one from me. In addition, I have 2 copies of my book, which I'm happy to give away. If anybody is interested, come up and see me. And I really appreciate your time. Thank you.